Okay, guys, so this summer you did some summer work where you reviewed the four different kinds of angles: the acute angle, the right angle, the obtuse angle, and the straight angle. We're not going to practice any more problems classifying these four kinds of angles because I know you reviewed that this summer, but just a quick reminder that acute has to be between 0 and 90 degrees. A right angle will be exactly 90 degrees, obtuse angle between 90 and 100 degrees, and a straight angle, it's just basically a line. Remember, we talked about opposite rays, right? It's a ray going this way and a ray going this way. And so between here and here is 180 degrees. Okay, another thing just want to mention, but don't want to spend a lot of time on, is that this device that we use to measure angles is called a protractor. And so we're not going to spend a lot of time on measuring angles with a protractor. We're mostly going to measures will be given to us, or we'll measure them in Geometry Sketchpad, but that is the physical device used in the real world to measure angles. Sometimes you'll see something like this in construction. It's the same idea. It's called a speed square, or a triangle. Somebody will just call it a triangle, and it also has degrees on it. And it's basically a right triangle protractor is all it is. So, okay, so angles with the same measure, we know that things with the same measure in geometry are called congruent. And so we mark congruent angles with an arc or multiple arcs. So this little arc right here and right here tells me that angle 1 is the same exact degrees as angle 2. Okay, so they can be turned different ways, but they have to have the same degrees. I could also give it 2 rings if I wanted to. That would also still denote they just have to have the same number of rings. Okay, so back to our investigation in the beginning about playing pool. So I asked you in pool, if I were to hit a ball, remember, and that ball bounces off the side, is it random in the way that that ball reacts? Well, it turns out there's vocabulary for this in physics. It's the angle of incidence and the angle of reflection. So you guys might have talked about this last year in 8th grade science, that the angle of incidence, the incident ray, is this angle here, at which maybe my ball is coming in towards the side of the pool table, and the angle of reflection is this guy over here. And it turns out that the angle of incidence is equal to the angle of reflection. And so in effect, think about it, that would imply that these angles down here are also congruent. So one way to think about this is the angle at which this makes with the side of the pool table should be congruent to the angle that it leaves that side of the pool table. And so it should bounce off at the same angle that it hit at. Now, in real life, there are different factors. If you have any bumps in the carpet on the pool table or fabric on the pool table, or if you have certain speeds or certain spins on the ball, it will react differently. But if your ball is just coming straight in a perfect world towards the side, it should leave that side of the pool table at the same angle. So if it came in at a 30-degree angle with the side of the pool table, it should leave at a 30-degree angle. So it'll be congruent angles. A nice little application there of real life. We just said that, so that's redundant. I'm going to mark that out. And let's answer some questions about congruent angles. So here we have, use the diagram at right, complete each statement. Angle MIG, so start at M, which is right here, to the I to the G. M to the I to the G is this angle right here with 3 congruent marks 3 rings. The question is, what is it congruent to? So what I'm going to look for is another angle with 3 rings. 1, 2, 3 right here. To name that, I'm going to go, remember the vertex has to be the middle letter, so I will go in the middle. So it'd be J to the I to the H, or you could call it J-I-Q or K-I-Q. It doesn't matter. There's multiple right answers there. I'm going to call it K-I-Q. How about? But just so long as I is the middle letter, that's the important thing, and then you have 1 point on either side of that angle. All right, so let's try another one. Same picture, new question. This time we're talking about P to the M to the J. P, M, J. If I trace that, looks like that one has 2 rings, so I'm looking for another angle with 2 rings. Okay, so H would have to be my middle letter when I'm naming that angle. I'm going to write over here rather than in the box. And so I could call that QHG or GHQ. Either one would be a correct answer for that one that it was congruent to. All right, now they're going to throw some numbers at us, same drawing. This time they said KJL. Let's find it. Oh, nope, went too far, Miss Benton. K to the J to the L. Looks like it has 1 ring, and they said it's 30 degrees. So then angle what would also be 30 degrees? Well, if these 2 angles are congruent, they both have 1 ring, it would also be 30 degrees. Now we just have to name that angle. It would be right here, so it looks like that might be MJI. Angle MJI. Again, you could have called it GJM. There's lots of things you could have called it. The important thing is J has to be the middle letter. Okay, and why don't you try this last one on your own? Why don't you try this one and then pause the video, try it on your own, and come back and check and see how you did. Okay, so it looks like LMP, I've got worked out here, is 100 degrees. And so QHG, Q to the H to the G, also has 2 rings. So those would have to be the same amount. They would be congruent. Okay, let's look at actually, let's pause right there and we'll start the next video. I'll see you in just a minute for us to talk about the angle addition postulate.